Acceleration in stage 1 means it's the final velocity that it has at the end of stage 1, v final 1. And then this is the initial velocity that it has, v initial 1. So it's v final 1 minus v initial 1 over t1. So the final velocity at the end of stage 1 minus the initial velocity at the beginning of stage 1 over the time for stage 1. Okay? The final velocity at the end of stage 1 is 0 because it has to come to a stop, minus the initial velocity at the beginning of stage 1. And remember this one, now we're going to use the assumption that I made. We assume that the car was initially already driving at the beginning of stage 1. So it's initially driving at 70 miles an hour. Okay, so let's assume there, then the beginning is 70. So the car probably started somewhere earlier, but we didn't start to time it until it got to that point. So you get 0 minus 70 divided by the time is 5/7. And this one is miles per hour per hour. So it's going to be miles per hour squared. And that's a legitimate unit of acceleration, miles per hour squared. And that one gives you a average 1. 5 goes into 7, that's 13 times, no, 14 times, right? 14 times 7, it's going to be 98, right? Negative 98 miles per hour squared. Now that one sounds like it's a big acceleration, but it's really not because it's miles per hour per hour. So it's really a slow acceleration. Now most of the actual acceleration is taking place towards the end when the car is stopping. This one is only the average acceleration. But in reality, the instantaneous acceleration is only taking place here towards the end. As the car sees that it needs to stop, it pushes the brakes. Okay, so that one is that. Now, A average 2, we could do similarly. The final velocity at the end of stage 2 minus the initial velocity at the beginning of stage 2 over t2. Okay? The final velocity at the end of stage 2. Now what is that? Well, when the car went over here, one of the other assumptions we made is that the car kept going to the left at a speed of whatever it was going. So its velocity here is negative 180 mile per hour. So we stopped the stopwatch there and we don't analyze it anymore. So its velocity there is negative 180. So that's the final velocity at the end of stage 2. The initial velocity at the beginning of stage 2 is 0 because it has stopped there. So minus 0 over t2. So that one is going to be what? Well, 4 goes, that's, what does that give you? Negative, what is it? 405 mile per hour square. Negative 405 mile per hour squared. Again, it sounds quite big, and it is relatively big compared to that. Now here we also notice something interesting coming out of this, is that notice in both cases the sign of the acceleration is negative. Now what does that mean, that it's negative? What's the physical meaning of that it's negative? Slowing down. Now, you're half right. Why? Well, the negative literally just means the direction is to the left. Negative 98, we could put formally here, we could put I hat, right? Negative 98 I hat, and then over here we could put negative 405 I hat. So the negative, all that it really means is that the acceleration is to the left. It's a vector and it is to the left. Now in stage 1, the car is going to the right and the average acceleration is to the left. A average 1. And in stage 2, the car is going to the left and its average acceleration is also to the left. A average 2. Now, is the car decelerating in both stages? Is it slowing down in both stages? Not really, right? In stage 1, it's decelerating because it's got to come to stop. In stage 2, on the average, it's accelerating. So it's actually picking up. Well, most of the acceleration is taking place initially here during the initial stage. The car has to hit the gas pedal and move that way. Okay? So what do we learn from this? We learn that when acceleration is negative, that doesn't mean necessarily that it's decelerating or that it's slowing down. Okay? So if we wanted to say, if we wanted to use the word deceleration or acceleration, this one we would call deceleration, right? And this one we would still call acceleration, even though it's negative. So when we say deceleration, what we mean is car slowing down. So it's slowing down in this case. In this case, it's actually speeding up. Acceleration means speeding up. So here's another thing we can learn from it. When the velocity and the acceleration are opposite direction, the car is slowing, an object is slowing down. You see? In the second case, the velocity is this way, and the acceleration is that way. When the velocity and the acceleration are in the same direction, then you're actually speeding up, even though it's to the left. You see? And this thing is going to apply later on when we learn of projectile motion or throwing something up. The same idea applies. When you throw something up, then it comes back down. Initially, the velocity is up, but the acceleration due to gravity is down. You see? When the velocity gets over here, velocity is like that, acceleration is still down. When it's over here, velocity is 0, but acceleration is still down. When you're over here, the velocity is down, acceleration is still down. So gravity always pulls you down. Okay? So if we wanted to use the word acceleration and deceleration, what would we say? In the beginning stage here, while it's going up, what is the object doing? Decelerating. And then the second stage, accelerating. Even though in both cases G is negative, right? G is down, so its official sign is negative J hat, right? But even though it's negative, or in the second stage, you're accelerating, okay? How about at the top? What are you doing there? Well, you're stopped for a split sec. Are you still accelerating or decelerating? Yes. Gravity doesn't shut off at the top. Okay? So which one is it better to say, accelerating or decelerating? Well, you pick your choice. Flip a coin. If it's heads, you could say accelerating. Tails is decelerating. So at the top, you can't really, either one. It doesn't matter. Okay, but definitely it's experiencing some kind of force up there, and its acceleration is still G, you know. Okay, so that's that one. Okay, how about A average total, the total acceleration? Okay, so A average total, what that is going to do